All right, so this is um, solving systems of equations by graphing. So you see that you have a 3 or 4 homeworks listed about solving systems of equations. So basically, a system of equation is just two or more equations. So you have at this point two variables. You have an x and a y, and you have two equations. There's 3 different ways to solve it, um, and one of them is graphing. It's kind of the most pain in the butt way to solve it, but still it's something that we cover because for you business people out there who um, intend on graduating and then becoming a multimillionaire through business, you are going to have to know where your break-even point is. And a break-even point is where year two, business functions, your cost and your profit intersect. So when we talk about um, a solution for two equations, and we're talking about it when that solution is a intersect, you're going to have a value for x and you're going to have a value for y. So if we just look at this example, here we have this equation, right? Boop. And here we have this one. So we have this line and this line. So solution-wise, we see that it intersects right here, okay? That's the intersection point. So the intersection point gives us our value for our x and our value for our y that work in both equations. And we'll see a little bit more with that later. So what is this point right here? Well, if we look at where it is, this point is at -2 on the x, and then +1 on the y. So it's over 2 and then up 1, so for this value. So your questions on the homework want you to answer them in this form. So that means your x equals -2 and your y equals 1. And you're most likely have times where to answer it where it looks like a point, because it is a point where they intersect. Okay. So questions that come up and you have to solve them by graphing is you're going to graph a line, and then you're going to graph the other line, and you see where they intersect, and that'll be your solution. If your questions are in this form, this is great, because this is in the slope-intercept form, right? So the number by your x is your slope. This number right here is your y-intercept. So that tells you where to start. So we're going to look at this line first. Y equals -2x minus 6. Okay. So what does that tell us? So what that tells us is that we're going to start at -6 on the y line, or y-axis. So we make a point there. And then this number right here, that's our slope. That tells us how to get to the next point. So if our slope is -2, that means I need a rise or fall in this case, since it's negative. And I'm going to fall 2, and I have to know how much to run. Remember, rise over run. So our slope, to give it a bottom, will be -2 over 1. So that means from this point, I'm going to go down 2 over 1. Down 2 over 1. Now, I want to make a nice line because I need it to intersect with my other line. So this is where if you just make a little dink line that sucks, then you're not going to see where they intersect. So, do that. So I saw this going this way. So I went down 2 over 1. But if I want to get some points over here, I just simply go backwards. So instead of going down 2, I'm going to go up 2. Instead of going to the right, I go to the left 1. Up 2. So I can see I'm going to have a line that's going this way. Now, your questions for graphing are on Newton, and they have graphs here. You don't have to do it by hand. But I'm going to do this first one by hand for you. Okay. The second equation is y equals negative 4x minus 8. Okay. So we're going to have a new line. And in this new line, it starts at negative 8 on the y-axis. So we're going to make a point here. And this is why I wanted to show you that backwards movement, because this slope is negative 4. So again, that'd be negative 4 over 1. So I would go down 4 to the right 1. Well, if I go down 4, I'm already off the graph, right? So in order to know this picture over here, I'm going to go, rather going down to the right, I'm going to go up and to the left. So from here, I'm going to go up 4 and then over to the left 1. I see it has that same point right there, up 4. So when I make this line, I see it intersects right here. So the solution to that is the x value at this point. So the x value here is negative 1. And then the y value is negative 4. So I believe they do something like this. And then they like bloop, bloop, like that. So our x value, negative 1. And our y value is negative 4. It's that point of intersection. Not too bad, right? Okay. We might have something that looks like this. Okay. So these two equations, the first one is given to us in y equals mx plus b form right here. So this is nice. This one is not. Okay. So again, this is why graphing is more of a pain in the butt. So to graph this, there's lots of different ways we can graph again, but kind of the easiest way is just to get it into that y equals mx plus b form. Okay. So our first equation is fine. It's already in that form. And then in our second equation, we're going to change that. All right, so I'm going to flip it back over so we can see the math to get this changed. Okay. So again, this is already cool. We have our y-intercept. We have our slope. So we're going to write in a negative 1 in front of that. This we're going to change to y equals mx plus b. So that means we have to solve for y. So I want to get this by itself. So I need to move this first. This is minus, so I need to add it. Again, not like terms, don't combine. They're just going to sit next to each other. This comes down exactly how it is. 3x plus 6. Okay. So now, to get y by itself, I'm going to divide everything by negative 2. And it's okay to have fraction for our slope. We like fractions for slopes. But I divided by a negative, so I'm going to have a negative slope. 6 divided by negative 2 is a negative 3. So in my equations, now I know I have this first one, and now my second one is in that form, and it's easier to graph. Okay. So here, So right here, there's not a number in front of x, but we can put a 1 in. So here our y-intercept is -1, and our slope also happens to be the same, but not always. Okay. Here, our y-intercept is -3, and our slope is -3 over 2. So going down 3 to the right 2. So on the question right here, it doesn't really matter, I think, which line, because you see there's a red line and a blue line. I don't think it matters which one you do. If we do this y equals -x minus 1, let's do that with the red line. This -1 means it's going through -1 on the y line. And that slope of -1 is telling us from that point, it's going to go down 1, to the right 1. Why they do this? Make it so small. Stupid. Okay. This equation up here, we changed it to y equals mx plus b form. That's going to be our blue line. And we're going to have it starting at -3. And then the slope again was -3 over 2. So from that point, we're going to go down 3 over 2. Okay. And so once you get your y-intercept and then that use the slope to get to the next point, basically your lines are graphed. And it has this point of intersection. So we see right here, this is where it intersects. So we're going to put this bad boy right there. And it looks like it's on it. So hopefully we'll submit that and it'd be right. Yay, we did it. Okay. And then it tells us the exact same thing that we did. Here, they did use the slope-intercept form. So the slope is -1 and the y-intercept is also -1. This equation, they didn't change it. They used the intercepts method. So they put 0 in for x, found the y. They put 0 in for y, or what did I say? Yeah, they put the 0 in for y here. And well, you know what I mean. Okay, so they got their intercepts. I don't like how they did that, but that's fine. Okay. Same thing here. So let's do this one. This first equation, it gives us the equation in y-intercept form. So this is telling me it's going to start on the y line at -10, and it has a positive slope of, here it says x over 2, but again, we can always put a 1 in front of x. So our slope will be 1/2, so up 1 over 2. So let's make this our red line. Let's start at -10. And then that slope was a positive up 1 over 2. There we go. Now this blue line, this leftover one, they have it as -4x minus y equals -8. So we could use the intercept method, or we could solve it for y. So let's do what they did. Let's do the intercept method, since some of you might like that, might prefer that over the other way. So, okay. So again, the name of the game for intercepts is 0. So we're going to plug 0 in for one of the values. That makes it go away. And then we solve for what's left over. And then we do it again, just reverse it. So I'm going to put here x is 0. So when x is 0, what's my y going to be? So I plug in 0 for x. Okay. This is 0. Anything times 0 is 0. But I still have negative y equals negative 8. Well, I don't want negative y. I want positive y. So if I think about that negative 1 in front, I'm going to divide everything by negative 1. All that does is change this sign. So if you change the sign of the left side, you're going to change the sign of the right side. So we have a point there of when x is 0, y is 8. It's going through the y line at 8. And then so we need another point, right? So first, I put 0 in for x. I found my y. Now I'm going to put 0 in for y. And I'm going to find my x. So substitute that in. Okay, so when you subtract 0, nothing happens. Goes away. And so now I'm left with dividing both sides by negative 4. So x equals a positive 2. So when y is 0, my x is 2. So I have my 2 points of the intercepts. I'm going to put those on my graph if I can get back to it. There we go. All right, so I've already moved this red line down. I'm going to use this blue line for my second part. And I found that I was going through positive 8 on the y line and a positive 2 on the x. So I see it's coming down here and going up there. I see it has a point of intersection. And I'm going to take that and plop it right there. Hopefully that works. Yay! All right. And they did the intercept method, yeah. Okay. So name of the game is see where those two intersect, and that will be your answer for x and for y. So you could use, in this case, you can use the intercept method we just did, and for both, or you can solve it for y. Get into slope-intercept form, or y equals mx plus b, graph it, and then again, see where they intersect. All right. And that is all I have for this one.